All right, so today we're going to take a little bit of a different stance. We have been doing order of operations for a few days now, and we're going to talk about this idea of evaluating what we call expressions. And first of all, we got to define what an expression is. Essentially, everything we've been doing with order of operations is an expression, because expressions have no equal signs. Okay? So you can never solve an expression because there's no equal sign to it. All right, so now you're going to be seeing letters, but with no equal sign, there's no solving. You're still doing the same thing you've been doing as far as an order of operations thing. So expressions, there would be something like 3x, y minus 3, things of this nature. You will see variables. All right. But they're things that don't have equal signs to them. And their instructions will always include this idea of evaluating. So what we're doing when we're evaluating expressions is we are going to be given a value for whatever variable is there or letter, okay? So I'm gonna say, okay, in this case, for these two up here, I'm gonna let x be equal to y equal to 7. Okay? What this means is if I am given the expression 3x, all right, I'm going to replace my x with the value that I'm given. Okay? The best way to do this, especially if you start having negatives, is first of all, write it out with an empty space where the variable would be. In this case, an x. And then replace where that is with the value given. Okay? And now I just have a simple multiplication problem. Is 3 times 2, which is 6. All right. If I do the same with the second expression I put up, y minus 3. Okay? And y in this case is going to be equal to 7. So I'm going to write it out with parentheses where my y is. And then I'm going to go ahead and replace that with the 7. So from here I have 7 minus 3, which gives me 4. And that is all we're doing. We're basically doing what we call plugging numbers in and then treating it like an order of operations problem and getting it down to a one-number solution. Okay. So let's go ahead and look at this set of problems. So I want to go ahead and evaluate these expressions when x is equal to 6 and y is equal to 5. Again, the first thing I'm going to do is rewrite it, but with a parenthesis wherever I see a letter. Okay, so in this case, my x gets a parenthesis, plus the 3 is there, and the y gets a parenthesis, so don't add anything extra there. And then I'm going to go ahead and say, okay, I know x is 6, and I know y is 5. Okay, and then from here, I could go ahead and use my order of operations, which means I must go ahead and do this multiplication first. So 3 times 5 is 15. And I can drop the parentheses around the 6, it's one number. So I'm just going to drop them on down. And then I have 6 plus 15, 21, and I'm done. Okay, next example, I'm going to have x squared minus y squared. So first thing I'm going to do again, parenthesis, exponent. And then the y gets a parenthesis, and it also has an exponent. And from here, I'm going to go ahead, plug my numbers in. So my 6 goes here, my 5 goes here. And then I treat it like order of operations. So 6 squared, or 6 is 6 times 6, which is 36. Minus 5. 5 squared is 5 times 5, which is 25. And it's subtraction, so I get 11. Okay. Number 3, going ahead and doing the same thing, not changing my ideas. So 3 in a set of parentheses, divided by set of parentheses for the y, plus 4. So going ahead, where x is, I'm going to plug in 6. Wherever y is, I'm plugging in 5. Okay. So 3 times 6 is 18. 5 plus 4 is 9, which gives me the result of 2. Last one for this set of problems. So I have -2 and x, so a set of parentheses, plus a set of parentheses for the y, and then the squared. Going ahead and plugging in my values, so I have 6 for x, 5 for y. Now a negative times a positive gives me a negative, and 2 times 6 is 12. Plus, we just did 5 squared earlier, 5 times 5, which is 25. Okay, now my signs are opposite, so I have to use my integer rules. And I need to go ahead and subtract these two numbers with the 25 being on top, right? And I get 13. And it's positive because my 25 is my bigger number, and it is positive. I'll do a few more here. So if we go ahead and look at these, now I threw in some negative numbers here. Still going to do the exact same thing. So wherever I have an x or y, I'm going to put a set of parentheses. I'm just going to rewrite it. And I know this may seem redundant, but it really helps because notice now my y here is a negative value, so I've got to be a little more careful. Okay, if everything's positive, it's a little easier. All right. So wherever I have my x, I'm going to put 3. Where I'm going to put my y, I'm going to go ahead and do this and put the negative in there. Now, because the y value is a -2, that negative has to go in there with it. But notice what it does to my signs. Look at this going on here. Now we have that whole idea of minusing a negative number. Okay, so keep that in mind as we go through this. So I have 3 cubed, which is 3 times 3 times 3. That's going to be 27. And I have minus a negative. So minus a negative is going to give me a plus 2. And I end up with 29. Okay, so when there's negative numbers involved in these evaluations, you got to be a little more careful. X squared minus y squared, same thing. I'm going to go ahead and put parentheses. And x is 3, y is -2. Now notice it looks similar to the other one, but now notice this 2, -2 is squared. Okay, exponent's got to come first, so do not pay attention to the fact that you see those double signs there. All right. So I have 3 squared, which is 3 times 3, which is 9, minus -2 squared, which is -2 times -2. A negative and a negative give me a positive here, and it's going to be a 4. So a 4 is going to go here. It doesn't change this sign here. These two have to still match. The positive part is coming from inside a set of parentheses. And 9 minus 4 is equal to 5. Okay, last one we're going to go ahead and do, so it's 2 times x, giving me a set of parentheses, minus 3 times y, another set of parentheses. Plug in my values for x and y, so I have 3 and -2. And I have 2 times 3 here, which is 6. And I can think of the second part in 2 different ways. I could think of it as a -3 times a -2, which would give me a positive. Or I could keep the minus sign and instead go ahead and just do, sorry, I want to change colors here, this part here without the sign. It is totally up to you and how you handle it. Okay. So if I do a positive 3 times a -2, that's going to give me a double negative kind of thing going on, which is going to give me a -6. Then you have to deal with this idea. I rather not do that. That's really not what I like to do with it. So I'm going to go back here, and I'm going to consider it a negative times a negative to give me a positive 6, and I will get 12. Okay, you guys pay special attention when you start having integers as replacement values, but with a little practice, it's really not bad. It's the same thing we've been doing the first 4 weeks of class. Okay, so I'll see you tomorrow. Have a great day.